Another beam question, very popular in exams and coursework in engineering or A-levels, things like that. So at this time, I've got a beam with a mass, no point load. So we need to work out what happens when you've got UDL. Here's my beam. I'm going to give it a length of 5 meters. It's got a UDL, which is equivalent to the mass. Uniformly distributed load of 3 newtons per meter. That means it's 3 newtons every meter. This thing's in balance. I'm going to assume it's in balance. We need to find RA and RB. The way you deal with this is, I'm going to convert the UDL into equivalent point load. So I'm going to do 3 newtons per meter times by 5, because there's 5 meters. That gives me 15 newtons equivalent. And what you do is you put that halfway, because the UDL acts across the entire length of the beam. So you put it halfway of where the UDL acts. You've got 15 and it's 2.5 meters in. That's equivalent. Makes it easy for us. Now we're going to work out RA and RB. I'm going to do force times distance. Moment is force times distance. Pivot point is there. The 15 newtons, the UDL wants to do this clockwise. RB wants to go the other way. That's the reaction. Force times distance is my first force. 15 equivalent times by, how far is that from here? 2.5. Going clockwise, leave it like that. We've only got one more force, it's RB, it's the reaction. How far is RB from my pivot point? 5. Which way is it going? Anti-clockwise. This beam is in balance, all add up to 0. Thank you very much. Do a bit of maths, that's 37.5. Bring this across to make it positive. RB times by 5. So 37.5 divided by 5 will give me RB, which gives me 7.5 newtons, which makes a bit of sense because we've got 15 smack in the middle. So that's going to be 7.5. And obviously RA is going to be 15, take away 7.5, which also gives me 7.5. What goes up comes down. 15 coming down, 15 coming up. Beam with a UDL stroke mass. Over and out.